Hi, everybody. My name is Filip. I'm tech lead for fleet orchestration and optimization at Waymo. And I know that you've been a whole day listening to talks and maybe your energy is a little bit depleted, so I might not be as energetic as the last talk, but we'll get through it soon. So let's first do a raise of hands. If you can tell me, raise a hand if you have heard about Waymo. Awesome, so many people. OK, now raise a hand if you have actually seen a Waymo on the street. A little bit less. And now, for those few, raise a hand if you have actually been in a Waymo driving. Nice, we have a couple. Congrats, guys. I think it's an amazing experience. So let's go on a journey, explore how Waymo uses AI and what Waymo actually is, so you get a better understanding of how it all works. This is Waymo. You can say hi. Oh, I'm missing a. There we go. Say hi to Waymo. These are our cars. And we are here on a mission to make our roads more safe and more accessible to everybody. And there's a reason for that. But first, our experience is that we've already driven millions and millions of autonomous miles that kind of gives us this experience and confidence into our systems. And one of the issues that we are having is that each year, over 1.19 million people die on our roads each year. So if you do the math, that's around one person every 26 seconds. And it's mostly down to human error. So as we were developing the technology, these are some of our stats that we actually show that autonomous technology can improve and increase the safety on our roads with over 90% fewer serious injuries or worst-case scenarios in incidents that were caused that Waymo was involved in, but doesn't necessarily mean that Waymo was the one doing in the incidents. We had 79 fewer deployments of airbags and over 90% fewer injury cases in those crashes. And safety is the core at Waymo. It's in the core of everything that we do, from engineering, from design, from the product development side. And with over 96 million miles driven autonomously in cities where we do service, we've already proven that we can be safe, not just for our riders, but also for traffic around us. We do regularly publish these numbers for safety. So if you go to waymo.com/safety, you can get all of the insights and all of the data, safety data, that we collect and publish publicly. We should have a video here, so one more time? No. OK, we'll skip. What might seem magical at first for our riders is actually a combination of sensors, AI, and technology that we use to kind of fuse and create this behavior. We'll start with what the Waymo Driver is and the hardware that we use, because first we need to see in order to decide what to do. Waymo uses cameras, radars, and lidars to sense the world around them. And this is for a good reason. It gives us insight in different modalities and different spectrums, and also provides us redundancy. So when we fuse all of those sensors together, we get an unparalleled view of the world around us, even up to 300 meters away in various weather conditions, rise or shine, day or night. And in the back of the car, we have a compute unit. And this is a data center level of performance that our engineers managed to squeeze in a pizza box-sized computer, which enables us to have autonomy on the vehicle. So when you put it all together, it looks something like this. This is what you would normally see at night as a driver. And this is what Waymo Driver actually sees. And the fidelity and the amount of detail and the surroundings, it's unparalleled to what you would experience driving. And with over 96 million miles, that's just about over 150 million kilometers that we've already driven. Imagine that's multiple lifetimes of driving. And in those lifetimes that we've collected, we've came across numerous different events that could happen on the road. Imagine those are scenarios that in your lifetime, it's a 1 in a million chance that you would actually witness something like this. And if I did my math correctly, if you do an average drive in your city and maybe go outside of your city, it's around 20 kilometers per year of actual car usage that you do. And to get to 1 million kilometers driven, it would take you 50 years of driving. So these are all the different scenarios, edge cases, and long tails of environments that we need to handle and we need to take care of. And you can select, you can group them in different categories, from extreme weather to unusual behaviors, foreign objects, or unique interactions. I have never seen a barbecue falling off of a truck on a highway. Have you? So it's just the collective knowledge that we use, and every Waymo driver, once we encounter or simulate or get to that point, every Waymo driver had that experience before and can then react appropriately. In order to get this to work, we've seen that we have a great hardware, a flow of sensors, and we have this great compute, but it's nothing without the AI that's running underneath. And great AI demands great input, but great input also demands great AI, because the sensors, even the most advanced sensors today, only provide raw data and raw inputs. They're not synthesized. It's raw data that you're getting from the sensors. It is the AI at the core that is transforming this data into actionable insights for smart driving decisions. And it works kind of like this. So you have Waymo AI at the core of the action. And what it is used for, it is used for to figure out where we are, where we want to go, what's around us, and what's going to happen in the future. And this complexity we are solving for to realize what's the next action, what's the next driving direction that we want to take that. We need to do this in a high safety critical environment with a low latency requirement. So it means almost near real time, we need to adhere to the highest safety standards of driving. So how do we get there? It's creating a state-of-the-art AI capabilities across our stack. It's not just what's in the car, it's the whole stack and how we approach development that matters. It goes from perception, where we use understanding of 3D world around us, to go from what we see pedestrians walking to actual 3D representations and locations of the agents in the scene, including their velocities, behaviors, motions, and predictions of where they are going to go at a much higher fidelity than what a human would do. Then we need to design generative AI for behavior that from the given inputs will provide us and generate the outputs for driving. Will tell us how much brake do we apply, how much steering, which directions we are planning to go into the future. And in the end, we do want to have a great simulation environment, because before we put even one bit of the new software, of the new AI on the road, we want to validate that it is safe, that it is going to behave in a way that we want it to behave. So that means that we want to have a great simulation environment, but to achieve the great simulation environment, we again need a great AI to achieve that. So at the beginning, we used CNNs, convolutional neural nets, for computer vision. That was the standard of the day decades ago. And now, as we were progressing forward, we had transformers, then we had the LLMs and VLMs that we use to kind of infer what's going on in the world around us. And we are moving for the future, where we are creating a Waymo foundational model of understanding of the world and driving decisions, how to move forward. So in our end-to-end multimodal driving, from our 2004 research, we are introducing Emma. That was a paper that showcased the ongoing trend for AI to apply large-scale multimodal learning to new areas. It was built on top of the Gemini. It was fine-tuned to process multiple camera inputs in environments from sensors to generate driving trajectories. It did behave as expected, almost out of the box, demonstrating the impressive power and generalizability of the Gemini model. While Emma is a research model with limitation, it's not yet sufficient for driving in the real world. But it provides high and immense potential for large multimodal language models for autonomous vehicles. So with our foundational model, it is more of a encoder-decoder system, where we take inputs for cameras, lidars, and lidars, and we kind of encode them in the input for the model, and then we decode it to generate driving instructions. driving plans, trajectories, future world states, and we can use this technology to then drive our agents in our simulations. And this is a sneak peek of our simulating environment, the worlds that we create in simulated world that help us validate, train, and deploy and retest our AI models that we are developing for driving. So let's do an example of how it actually works. I've talked a lot about multimodal AI models, about how we use encoder, decoder to transfer the input from the real world to the outputs. But then we have to go back and think about it's not just about the software here. It's not just about the AI. We've heard across these years, the LLMs, they're everywhere. They're in virtual world, and they are creating virtual tasks. Waymo is the currently AI that's operating in the physical world in present. It is most advanced demonstration of how AI is behaving in reality. So that means that we have real world constraints. It's not just generating tokens, it's not generating text, it's actually doing impact and changes to the real world. So we start from defining the objective that we want to achieve, and in this case, we want to drive on snow. So we need to define all the behaviors, all the scenery, and all the expectations that we can have for driving on snow. Then we go defining what we need and designing sensors, inputs, and behaviors, not only in digital world, but only in physical world that solve problems and achieve goals that we want to achieve. After we did the design, we need to validate that the design actually works through rigorous testing and repetition of making sure that what we are building is safe and ready to go on the road. After validating, we deploy it. We collect data from the real world, from the behavior of the vehicles, and then you go back into the same loop where you do define, design, validate, deploy, and continuously improve every Waymo rider that you have. Currently, we are developing the 6th generation of Waymo that's going to be using more cost-effective sensors, but offer greater performance both in driving capabilities, but also in compute. And it's going to be debuted on the Zeekr and Ioniq 5 platforms. In the future, we are bringing Waymo to many more places. As you can see across the US, it's a great amount of cities, but maybe what we are currently thinking about the most is London, which is the closest one that's going to be available to us, as well as Tokyo in the future. And those cities also present a new challenge of driving on a different side of the road that we were used to do. Fortunately, Waymo adapts and generalizes really well, so getting into those kind of scenarios was not a hard issue to resolve for. Well, this has been a journey from the beginning, and it's been decades into the making. Waymo is currently serving riders. We have hundreds of cars this very second serving riders fully autonomously 24/7. And remember, it's nighttime in the US, so we still have hundreds of cars driving around and serving riders. If you're interested in defining the future of autonomy and the future of driving, join us. You can reach me after the talk behind the stage, and I can answer the questions you might have. Thank you.